Okay, let's go ahead and check your answers to number 9. This has arrows at both ends, so we know it's called a line, and we name it with its 2 points. And so we have 2 different ways that we can name it. We can name it line BA or line AB. The order does not matter when naming a line. This one is a ray. It has a definite beginning, but it goes on forever in one direction. So we only have one way that we can name that ray. That's ray AB. The next ray starts at point B and goes forever in direction of point A. And so that one is called ray BA, which is this one. So don't get those two mixed up. The next one has a definite beginning and a definite ending, and so that's called a segment. We use segment bars for that. The order does not matter in those points, so we can call that segment BA or segment AB with symbols. When we're talking about the distance between the 2 points, remember you're going to drop this symbol. And so you could say either AB equals and give the measurement in a number amount, or BA equals, but no symbol above it. So we'll see that, yes, we got them all correct. Be sad if I missed one, wouldn't it? Okay, let's look at number 10. See how you did on it. Practice naming the angles, matching the angle to its correct, or matching the name, I should say, to the correct angle. Okay, so if we're talking about this angle, right here, with the F and the A and the E, we can name it with 3 letters, but we remember the vertex has to be in the middle. So the point they have in common is point A, so A has to be the middle letter. So we can name it angle FAE or angle EAF. A has to be in the middle. On this one, the C is the vertex, so C has to be in the middle. So we have to have D and C as 2 of the points. Now going this direction, we can either use A or E. It doesn't matter. So we're looking for the ones with C in the middle. Here's DCA. That's an option. And here's ECD. So notice this one used A on this side of the angle, and this one used E. But those are still talking about the same exact angle. So over here, B is the vertex, so it has to be the middle letter. On this side, we can either use point A or F. On this side, we can either use point C or D, okay? But we're looking for B in the middle. So here's CBA, that's one of our answers. And here's one that just has angle B. There's not another one with B in the middle. And so we can name that angle B as well. So this one could have been FAE. Make sure you don't name that as angle A. Okay, we can't name this one angle A because I wouldn't know which angle A you're talking about. Are you talking about this angle A, this angle A, this angle A, or this angle A? So make sure on this one that you don't choose that as one of the answers as how to name it. You have to use the 3 letters on it. Okay. Same with this one. We can't name that angle C because I wouldn't know if you're talking about that angle C or this angle C. So this is the only one we can name with 1 letter. There's not another angle B to get it confused with, so when I say angle B, I know exactly which one we're talking about. So we'll get those correct as well. All right, so the next thing we're going to briefly talk about are supplementary and complementary angles. When we talk about supplementary and complementary angles, we're talking about a pair of angles, so there has to be 2. And we're talking about what their specific sum, which means adding the 2 measures, has to equal. So these are examples of supplementary angles. Supplementary angles have to be 2 angles with a sum of 180 degrees. The 2 angles have to add to be 180. Now, these 2 angles share a side, so we call those adjacent angles. 85 plus 95 is 180, so that's a pair of angles that add to 180, so those are supplementary angles. These 2 don't share a side, but they still add to be 180 degrees. They are also supplementary angles. So they don't have to be adjacent to one another to be supplementary. Okay, complementary angles are 2 angles. I guess I missed that little down here. I need to scroll down. Where's my scroll down? It's kind of hard to hold the computer like this. Okay, here we go. All right, so when we look at complementary angles. I'm going to go one more here and get my computer to cooperate. We're going to talk about complementary. There we go. So when we talk about complementary angles, we're talking about a pair of angles or two angles that have a sum of 90 degrees. So these two add to 90, these two add to be 90. Again, they don't have to be adjacent to each other. These are adjacent, those are not. Okay? So, a couple more things to talk about is just how do you remember the difference between complementary and supplementary. So I have a couple of tricks here to help you. So one is just because of the fact that the letter C, which is the starting letter of complementary, comes before the letter S for supplementary in the alphabet. And so then you can think numerically. 90 comes before 180. So C goes with 90, S goes with 180. Another way is when you write the words themselves, you can quickly turn that beginning letter C into a 9 just by drawing a stem. And so that reminds you that's 90 degrees. The S you can quickly make into an 8 by just connecting those two ends and reminding you of 180 degrees. Another way is to remember this phrase. It's always right to give compliments. And that means you're telling something nice to someone. Just note that these are not spelled the same way. So when you compliment someone saying that they look nice today, you're using an I here. When we talk about compliments in math, we use an E here. So if I want to know what's the complementary angle to a 30-degree angle, its complement is whatever you would add to this to equal 90 degrees. So 30 plus what is 90, that would have to be 60. So 60-degree angle is the complement to a 30-degree angle. All right, so let's throw a little algebra into it. Always like to keep those algebra skills fresh. So how would we solve this problem? Two angles are complementary. So we know now, complementary means the two angles must add to be, hopefully you know, it's 90, right? I can make that C into a 9. The larger angle is 18 less than 5 times the smaller. What are the measures of each angle? So hopefully you recognize that we have two unknowns because we have two angles we're trying to find the measure of. So we can use variables to represent those two angles. So this is the first angle. This is the second angle. It really doesn't matter which one you name which. Okay? Now, if I say that this is the larger one, then I have a way to represent the larger one in terms of the first one, which is x. It says the larger angle, which is my y, is 18 less than 5 times the smaller. Well, I know how to write 5 times the smaller. If I'm using x as the smaller one, 5 times the smaller is simply 5x, right? And if I want 18 less than that, what does less mean mathematically? It means we're subtracting. So I want to take the 5 times the smaller, and I want to subtract 18 from it. Make sure you understand that's not the same thing as 18 minus 5x. This is not 18 less than 5 times the smaller. You have to start with the 5 times the smaller and subtract the 18 from it if you want 18 less than that. Okay, so now I have y in terms of x. So this is my larger angle, this is my smaller angle. They're both with the variable x now, and I know they're complementary, which means they do what? They add to 90. So I can take the x and add the 5x minus 18 to it and set that equal to 90 degrees. So now, since it's just one variable involved, I can solve this algebraically with one equation. I can combine my like terms, 1x and 5x together make 6x. Then I can undo the subtraction of 18 by using addition, adding 18 to both sides. So I have 6x equals 108. And then I can undo the multiplication by dividing both sides by 6. So my answer for x, I get x equals 18. Now make sure you answer the question. It says, what are the measures of each angle? X only gives me the first one, the smaller one. The smaller one is 18 degrees. The second one, I can find two different ways. I can do 5 times this one and then subtract 18 from it, or I can remember that they have to be complementary. So I can simply take 18 from 90 to find out that that second one is 72 degrees. So I know that those add to be 90. I also know if I do 5 times 18 and then subtract 18 from it, I'm going to get 72 that way as well. So this is my answer, 18 degrees and 72 degrees. All right, so before we leave today, I want to make sure there's some things that you learned, okay? Why do 3 collinear points not define a plane? Remember we talked about that. If I have 3 collinear points, there's infinitely many planes that can go through those 3 points. They have to be non-collinear to represent a specific plane. If 2 points lie in a plane, what can you say about the line that is also defined by those 2 points? So I have 2 points on this sheet of paper, okay? The line that I would draw through those 2 points is also on the same sheet of paper, right? So if you have 2 points on a plane, then the line defined by that is on that plane too. It's also on this sheet of paper that we're representing a plane with. What are 3 possible ways that 2 lines could intersect? Okay, so here I can draw 2 lines that intersect. They intersect at a single point. That's one way. The second way is I could draw this line and I could draw the second one right on top of it. That was beautiful, wasn't it? Okay, so they could contain every single point in common. That's another way they could intersect. The third thing that could happen is for them not to intersect, but that kind of goes against what it says. It says that they could intersect. But that's a third possibility, is that they wouldn't intersect at all. And remember what we call those lines? They're called parallel lines if they're in the same plane. Okay? If they're not in the same plane, and what I mean by that is, let's say that I have this situation here. I'll just put a different sheet of paper here. I don't know if you can see that. But I'll draw a line here, and I'm going to draw a line here. Okay? So, can you kind of see that? Okay, so here's that line. Okay, it's in this plane, and here's that line, and it's in this plane. Are those lines ever going to intersect? No. Okay, this one's going to go forever this way, this one's going to go forever this way, it goes underneath it, but they're not parallel to each other. We have a different word for those. If they're 2 lines in different planes not intersecting, those are called skew lines. So that's a vocabulary word you'll need at some point. These are parallel, they're in the same plane and not intersecting, and those 2 that I talked about are skew lines. So hopefully you've learned something today that you didn't know before. Good luck on your homework. I look forward to seeing you guys again on Monday. Have a great weekend.